This is the fourth and final video that I'm making about this formative that we did on functions. In the first one, we talked about the details of this particular graph and how to identify the key features and also how we write those key features. The second video, we talked about how to evaluate a function like this function here, g of x equals x squared minus 1. And in the third video, we talked about how to write a function, the equation of a function, and then how to use that equation to determine the domain and what possible restrictions there might be on our domain depending on the function. And then finally, in this video, we're gonna look at function composition. And there's again, this is for people who are new to functions. These compositions can be a little bit tricky, but I think we can make sense out of it with these 5 examples. So we're given 3 functions: f of x, g of x, and h of x. And it's worth noting something really right out of the gate about the function g of x. You know, up until this point, we've been taking the square root of a number like 9, let's say, and reporting the result as either positive or negative 3. And you might recall, like in the quadratic formula, we actually have there's a square root in the quadratic formula, and we say a negative b plus or minus the square root of et cetera, et cetera. And I want to just acknowledge a couple things. I could probably have done a better job on this question by saying that consider these 3 functions, f of x, g of x, and h of x, and find them in the simplest terms. And it's important to acknowledge that these are all functions, because if I wanted the positive number 5, I would just write this. When we see a number like that, we assume that it's positive. If I wanted negative 5, I would have to write a negative sign. And if I meant both positive and negative 5, maybe I could put a plus or minus, or I might write positive 5 and then negative 5. Or I should say, really, we just write 5 and negative 5. And so when we are in the context of functions, when you see a square root, we just assume the positive square root. G of x is equal to the positive square root of x. I actually did write it up here in this the latest version of this formative. Take the positive square root. If I wanted the negative square root, I could have a function that gives me the negative square root. It's just fine. I take the positive square root, I make it negative, and I give that function a different name, like j of x or something. And if I tried to combine these together into one function, then they would no longer be a function at all, because if I had a plus or a minus square root of x as my output, right, there's a particular input x that would give me 2 possible outputs. That's not a function. So again, I could have been clearer about that here, and we'll see that's going to be an issue when we do this first letter A. And let me just take this apart a little bit. It says g of h of 20. So what I really want, in order to figure this out, the first thing I have to do is figure out what that is, h of 20. So I've got h of x right here. It's x minus 4. So h of 20 is just going to be 20 minus 4. So really what I want is g of 20 minus 4. So let me take that 20 minus 4 and evaluate it. I get g of 16. And now I can use the rule that is defined here for g. G of x is equal to the square root of the x. So g of 16 has got to be equal to the square root of 16, which is 4. And I know we're very much in the habit of writing plus or minus 4, but remember, these are functions. And if I wanted the negative square root, then I would have to indicate that in my function rule, like I did over here. So the answer is 4 for A. And let's do the same thing with B, f of g of 10. So what I really want is f of whatever g of 10 is. Well, the function g takes the square root of its input. So I want f of the square root of 10. And if I look at the function f, it's the squaring function, right? So whatever's inside of here, I'm just going to square. So I take my square root of 10 and I square it, and of course I get 10. And that's interesting. You know there's a special relationship between squaring a number and taking the square root of a number. And if you first take the square root of something and then square it, you're right back where you started. And that's an important idea that will come back to us in as we continue studying functions. But here we go. Letter C, f of h of x. So what I really want is the input to my function f, which is the squaring function, and we'll get there, but the input is just plain old h of x. So I'm going to put the x minus 4 in here. I was able to put 20 up here because I knew what value of x I was evaluating this composite function at. But here, I don't know. So I'm just putting the entire expression that h of x gives us here inside of f of x. So what I want to do now is I want to square whatever's inside, whatever's my input is. And so that's just x minus 4. So that's my solution. It does say find it in simplest terms. And I know in an earlier video I said, well, usually when you have a quadratic, the simplest terms are when the quadratic is just in standard form. And arguably this may be simpler. It's a perfect square. And you can leave your answer like this. But if you happen to write x squared minus 8x plus 16, that's fine too. As long as you don't have, two terms that can be combined together, or any more algebra or arithmetic that you could do in order to make it look a little simpler. Now this notation is really the same as this. It's just a different way that we compose functions, a different way that we write h of f of x. So I'm going to just put that here. I like writing it this way because it makes it very clear that we're actually we're evaluating a function with the rule of another function. H is the function x plus 4. So, and f of x is just the x squared function. So what I'm really doing is, and I'll do this in a bit of a different way, let me take the function h. Whatever my input is, I'm just going to subtract 4. But in this case, the input is actually the function f of x, which is x squared. So I'm just going to put the x squared right in there as the input. And that's a little bit simpler if I just remove those parentheses, and that's my h of f of x. And now we've got all three functions. We've got a composition of three functions. G of f of h of x. That's a lot. So let me just begin by going right here to the h of x, and I'll say this is g of f, and instead of h of x, I'm just going to put my x minus 4 in there. G of f of x minus 4 is what that is. And I can go a little bit further now, and I know that f of x is the x squared function. So let me square my x minus 4, and I get g of x minus 4 squared, like that. And then the rule, the function g is the square root function. So now I'm just going to take the square root of x minus 4 squared, and that's going to leave me with a plain old x minus 4. That is the simplest form right there. And so you'll notice that a couple things, like this right here is just f of h of x, which we figured out up here. This is f of h of x. So really I ended up here just with with the same thing I had here. And then also we have a g of f in this composition. And just like f of g, when you square root a number and then square it, you're left with the same thing you started. If you do g of f, what you're doing is you're squaring something and then taking the square root, and of course you're just left with the thing you started with. So that is a bunch of examples of function composition.